Hello, this video will cover section 2.2, properties of and simplifying exponential expressions. This video is for the class Math 0305 with the co-requisite of Math 1324. The objectives of this video is to use the properties of exponents to simplify expressions and to be able to convert from fractional exponents to radical form and vice versa. So when we say radical, think about square roots, cube roots, fourth roots, and so on. So before we get to that, we are going to, when some of our problems, we're going to be dealing with numbers, and others, they're going to have variables, and others, there will be a combination of. So whenever we have two variables that are the same letter, I guess, and we are multiplying them, what we need to do with the exponents is we add them. So this will be a to the power m plus n, and so that will give me a to, well, in this case, they're letters, so that will be the answer, a to the power m plus n. If m and n were numbers, we will actually add them, but in this case, we would just leave them like that. Next one, we call it the quotient rule. So if you are dividing two letters, what you will do with the exponents is you subtract them. So m minus n. For the next one, we have the power rule, and in this case, you will multiply the two exponents that you have here, m times n. The next one is a to the power 0, and that is equal to 1. In fact, anything raised to the power 0 is 1, except for 0, because 0 to the power 0 is undefined. Anything else that is not 0 raised to the power 0 will always be 1. Even, let's go to example F. So in this case, we have this whole expression, but the fact that it's just raised to the power 0 is just telling me that it's equal to 1. So I don't even need to bother to find out what x, y, and z equal to. The whole thing is being raised to the power 0, and therefore it's just equal to 1. So going back here to our fill-in-the-blank statements, we have the power of a product rule. So this is like a combination of product rule, but also with the power rule. So in this case, what we need to do is distribute the exponent, in this case n, to both the a and the b. Next one is similar, but now we're going to combine power rule with quotient rule. So, but same thing, we will have a to the power n divided by b to the power n. And we're going to use these rules to our convenience. So sometimes it might be more convenient for us to go from left to right or right to left. Now we have this one of negative exponents. So anytime you have a number or a letter raised to a negative exponent and you don't want to have that, you could, if you don't have a denominator already, you assume it's a 1. So in this case, I'm going to interchange places of the numerator and denominator. So it will be 1 divided by a to the power n. And that will take care of the negative sign of the exponent. Now, this one is very interesting because fractional exponents are actually radicals. And we could say, for example, an easy example will be the square root of x. Now, in this case, we have this little number here that is called the index. For the square root, we don't write the index. However, we know it's a 2 because we call it the square root. We don't call it the first root or the 0 root. We call it the square root. So this expression could also be represented in this way, to the 1/2. Now, what if I put x to the power 3 here, and then out here, I want to put the 5th root? Well, in this case, we will have x to the power 3 over 5. So whatever is the index for our radical will always be the denominator of the exponent. And so to expand this one here, we could say that it is a to the power m and then the n root. Or we could say the n root of a and then raise to the power m. And those two expressions are equivalent. Now let's get started with the examples. So the very first one that we see here, we see negative and it's not enclosed in parentheses. So what that means is that you have a 1 and then you have 6 multiplied by itself, 6 times 6. So in this case, we have negative 1 times 36, and the answer for that will be negative 36. Now, just for fun, let's write down what would happen if the negative was inside the parentheses. So if we had negative 6 to the power 2, what that would mean is that you have negative 6 multiplied by itself. And that negative times a negative will give us a positive solution. So that will be positive 36. So it does matter if you put parentheses or not around the number you're substituting. So let's move on to example B. And in this case, we're going to multiply the coefficients. So 3 times negative 4 is negative 12. And now with the letter, the variable y, we're going to have the exponents 2 plus 4 adding each other because we're using the product rule. So this will be negative 12 y to the power 6. Next problem, we're going to use the power rule. So we have x to the power 4th raised to the power 2. And so in this case, it's like if we had x to the power 4 times x to the power 4. Right? X to the power 4 multiplied by itself. And so we do know that we do add the exponents here. 4 plus 4 is 8. Now, just by going the shortcut power rule, we take these two numbers and we multiply them, and we get x to the power 8, which is the same thing. So it is helpful to know the rules. Now, right here, example D, it is a combination of the power rule and the product rule. And so for that one, we say that we have to distribute the exponent that is outside to every single factor inside. So we're going to have negative x raised to the power 6, and then we're going to have y to the power 4, but now raised to the power 6. Now from here, if we have negative x multiplied by itself 6 times, that will give me positive x to the power 6. And that is because if you have an even exponent, in this case to the power 6, negative x times negative x will give me x squared. And negative x times negative x will give me another x squared. And negative x times negative x will give me another x squared. So this will end up being x to the power 6. So whenever you have an even exponent and you are raising a negative base to that exponent, your answer will turn that base positive. Now for this one, we need to multiply those two exponents, and that will give us y to the power 24. And that is just the final answer. For the next example, E, we are dividing the letters. So in this case, we have to subtract the exponents. And so that will give me x to the power 4. F, we already did that one. Anything raised to the power 0 is equal to 1, except for 0 itself. Next one, we're going to use the negative exponent. So we're going to take the reciprocal of it. In this case, we'll bring the 1 over to the numerator, and the x with the exponent to the denominator, and that will take care of the negative sign. Now the next one, only the x is being raised to the power negative 3. So in this case, I can write this way. 1 over 3. I'm going to just separate them for a second. And then I'm going to have here x to the power negative 3. Here I'm going to put a 1 on the denominator. And so this one, I could change it to 1/3 times 1 over x to the power 3. Because if I take this x to the power negative 3 to the bottom, we'll make the exponent positive. So from here, we can multiply straight across, numerator with numerator, so that will give me a 1. And then denominator with denominator, so that will give me 3x cubed. And so that will be the final answer. This 25 is just the page number. So let's move on to page 2. Now here we have 7 to the power 1/2. And just like I showed you previously, that implies that we're talking about the square root of 7. Of course, we do not write the index for the square root, but we know it is there. So it will just be that, the square root of 7. For the next example, we have 4 divided by 1. And then we have x with a fractional power, and moreover, it is negative. So first, let's take care of the negative sign. And this will be 4 over 1. And now I'm going to move the 1 up here, and the x to the power 4/3, now positive, it will be on the bottom. Now from here, we could say that if we multiply straight across like that, we will get 4 over x to the power 4/3. Now, the instructions are to turn it into radical form. So here we're going to have two options. We could either say 4 over x to the power 4, and then we will put that in the cube root. Or we could also write it this way, 4 divided by the cube root of x, and then all of that raised to the power 4. Both expressions have the same meaning, and they're both correct. Now, the next one, we have the whole expression, including the coefficient raised to the exponent. In the previous example, this big number was not raised to the power negative 4/3, but in this case it is in example C. So what we got to do first is make sure we do distribute the exponent, but before that, let's just take care of the negative sign. So I'm going to assume there's a 1 on the bottom, so now I can flip it and it will be this, 5x to the power positive 5/4. Now from here, we have two options to write our answer. One of them could be with the 5x enclosed in the 4th root, because that is the denominator. And then we will raise all of that to the power 5. So that is one option. The other option is to have 1 over 5x to the power 5, and then after that we take the 4th root, like that. So those two expressions are equivalent again. Next one, we have 10n to the power 3/2, and so this one could be the square root, of course we don't need the 2, but I'm just going to put it there, of 10n to the power 3. Or we could have 10n inside the square root, and then we could raise that whole thing to the power 3. So the 3 is this 3 here, and the denominator 2, that will always be the index of the radical, of the root. Now moving on to example E, that one is pretty simple. It would just be the square root of x. Remember the index, we don't need to write it, it's just imply that it is a 2. For the next one, first I'm going to take care of the negative exponent, so this will be 1 over x to the power 1/2. And so in this case, it will be 1 over the square root of x. For the next example, first we're going to make this exponent positive. So it will be 1 over x to the power 3 over 8. So in this case, we could have 1 over x cubed and then enclosed in the 8th root, because 8 is the denominator, therefore it should be the index of my root. Another way to write it, it will be 1 over, and then we will place x in the 8th root, but then we will change that to the 3rd power. So those two are equivalent. For the next example, 8 to the power 6 over 5, we could have 8 to the power 6, but then we need to have, in this case, the 5th root. Or we could start with saying the 5th root of a, and then the whole thing will be raised to the power 6. So those two answers are equivalent. Now for example 3, we are required to do the opposite of what we did. So we're going to go from radical form to exponential form. Now in this case, both 6 and p are inside the square root, so we're going to use parentheses and say that that whole thing is raised to the power 1/2. On the next one, we have the root will be 1/4. So we could say this is m to the power 1/4, but then we still have that raised to the power 3. And so if we simplify that by using that power rule, it says to multiply those two exponents, so that will be m to the power 3 over 4. Remember, when we multiply fractions, we multiply straight across, numerator with numerator, denominator with denominator. The next example, and now we have a cube root, and so that will be the denominator of the exponent at 3. And the numerator will come from here. So 6x to the power 4/3. I use parentheses because the whole 6x was inside the radical. For the next problem, we have 1 over x to the power 1/2. So we can leave it like that, or if we're required to have negative exponents, it will be x to the power negative 1/2. Now the last two will be 4 over, and in this case we have x to the power 4/5. And that is because the exponent, the index is a 5. We're talking about the 5th root. So then the exponent, it makes sense that it will be a fraction with a denominator of 5. Now, if we wanted to move that x to the top of the fraction, to the numerator part, we could do that, but then that will cause the sign of the exponent to be negative. So that depends on what the question is and what is more convenient to your problem. This last problem will be 1 divided by, again, 3k in parentheses. And we could say all of that to the power 5, but then everything is inside the cube root. So to the power 1/3. And again, just to remind you, we multiply the exponents in this case. So it will be 1 over 3k to the power 5 over 3. And if you were required to have 3k on the numerator, it will be 3k with the exponent negative 5/3. So this is the last problem. This is the end of the video. Thank you for watching.